ado, I'd like to just hand over to Sarah, who is the Chief Program Engineer of Engine Engineering at Ford Motor Company and has been doing this for nearly 25 years, I think, is it, Sarah?
Yes, it's a long time.
Yeah, fantastic. A lot of experience there. So I'm just going to stop sharing my screen now, and then you should be able to share yours.
Okay. All right. Well, good afternoon, everybody. As Alex mentioned, my name's Sarah Haslam. Let me share my screen with you. Hopefully you can see that now. And this afternoon, I'm going to talk to you for about 10 minutes and then try and answer any questions you might have about automotive engineering. But firstly, I wanted to start with, what is an engineer? What is engineering? Well, engineering is almost everything around you, whether it's something you eat, something you wear, what you use and what you like to do involves some sort of engineering. So for example, developing the mobile apps and computer games of the future, making better, greener, safer transport, minimizing damage from earthquakes, and even working with athletes to help our nation succeed better at sport. We can also help everyone in the world to have better access to clean drinking water. And we can research and develop life-saving medical equipment, very important currently, of course. And we can create the right lighting and sound sets for music festivals. And a bit further afield, we can develop and design satellites enabling space exploration. We can also develop futuristic fashion, fabrics and wearable technology. And finally, create an infrastructure from sports stadiums to rail networks. A bit about what engineering is about, but what is an engineer? Well, engineers use maths and science in a very practical way. We really do make a difference to the world, as most importantly, we solve problems. Here is a list of school subjects that really lead to real-world engineering: biology, chemistry, design and technology, information and communication technology, maths, and of course, a bit of physics. Any of these will help you become an amazing engineer. You could be involved in designing the latest sports equipment for our next generation of cosmetics, or even new technology on mobile phones. Let me tell you a little bit more about me. At school, I loved maths and physics and found them really easy too. I had a passion for fast cars by watching Formula One racing on TV with my dad. So I feel very lucky to have been working for Ford Motor Company for nearly 25 years now. During this time, I've had many different roles. So let me tell you about some of the best ones. So as a design engineer, we break the car down into bits, components. And one of my first jobs was designing windscreen wipers, bumpers and sunroofs on Fiestas. Design the parts, test them so they worked for at least 10 years, and make sure that they could be assembled into the car in the assembly plant. I would like to show you a YouTube clip, a short video of one inside our factory to show you how we make Fiestas, but it's not working very well on this Zoom conference. But what Alex has done, hopefully, is copy and pasted the link for the YouTube clip, and maybe you can look at it afterwards. It's a really good video showing how we build Fiestas, and it's shown in 86 seconds how we build each Fiesta. So that's something perhaps you can look at later.
I've posted it in the chat, like you said, Sarah.
Right.
What's the actual name of the video on YouTube? Do you know?
It's How We Build Fiestas in 86 Seconds is the title of it.
I'll type that title in as well. Thank you very much, Sarah.
Thank you. So hopefully you guys can watch that after this, because it's a really good little video showing what it's like to be inside one of our factories. Another great job that I've had is being responsible for a new diesel engine in our transit vans. Hopefully you all know what our transit vans look like. Well, the engine in the van is what I worked on, and it was produced in 5 different countries: England, Turkey, Thailand, South Africa, and even Argentina. So that meant I had a lot of travel to the engine plants to make sure they were building my engine correctly and with quality, so that our transit customers didn't have any breakdowns. I mentioned travel there to 5 different countries, but being an engineer working for a large company will mean travel all over the world is necessary. Here are a few of the places I've been to: Australia, America, China, and lots of countries in Europe. More recently, I've just returned from Valencia in Spain. I was on a 3-year manufacturing special assignment based in the factory. I was responsible for 2 vehicles, the Transit Connect and the Cougar, to make sure that the quality of the vehicles was the best that we could. The 2 vehicles are of 5 different vehicles are actually built in the plant, and we're building approximately 2,000 vehicles a day. So it's called one of our mega plants. The job was very, very challenging and demanding. As you can imagine, if something went wrong on the production line, it had to be fixed really quickly. And the benefit, though, was, of course, living in Spain. I was living in Valencia city centre for that period of time, and it was an amazing experience. Finally, my current job is ensuring we have engines for Europe that meet the emission CO2 requirements for many of our vehicles. The future of engines will change as we move to more hybrid use of batteries to help the environment. And that is the future that you could help solve. Thank you very much for listening to me. And I'll now pass over to Alex to see if there's any questions that you might have for me. And perhaps we can put the video camera back on as well. That'd be great.
Yes, fantastic. Thank you very much, Sarah. I'll just put your video on as well. If you click on the stop share screen, Sarah.
And stop sharing.
Perfect. There we go. Fantastic. So what I would like to ask everyone to do, if you will be able to type in the Q&A section, if you type in your questions for Sarah there, it might take a while just for some to come through, Sarah. The same on the YouTube comments as well, on the YouTube chat, if you could type in your questions there as well, so I can read some out on there. And then I'll ask some questions as well, just while some are coming through. But I think we've already just got one through from Susan. So it's, what age were you when you knew you wanted to be an engineer?
Yeah, good afternoon, Susan. Well, that's a great question. And I was actually 16, 17 years old. I mentioned I really loved maths and physics at school. And I was lucky enough to go on a weekend course to a university in London using WISE, and that's Women in Science and Engineering. They were running a weekend course at the university to encourage young female students to think about engineering as a career. So I had 2 great days of workshops and sessions with real female engineers, and they made me realize, do you know what, this is something that I could do. I really enjoy maths and physics. Engineering's a great combination of the both. And once I'd met some real female engineers and understood what they did, I thought to myself, this is something I could do. And then I went on to study engineering at Bristol University. So great question, Susan. Thank you.
Thank you. If people, some people put it in the Zoom chat, if you could type, I think Hannah and Caroline, if you could type yours into the Q&A, just so they all come up in the same list there, that would be perfect. We've got quite a few questions coming in, Sarah. So the first one I can see is, what is your favorite car? That's from Rashantha.
Well, I'm going to have to say 2 different things here. I think the first one, I'd have to say my favorite Ford car. My favorite Ford car is a Focus ST, and I like it in the screaming orange color as well, with the fast petrol engine in it. And I won't tell you how many speeding tickets I have, but it is a great vehicle to drive. So that's my favorite Ford vehicle. But I think if I was have to tell you what my favorite perhaps racing car or superstar is, I think I'd have to pick any Bugatti. I think any Bugatti would do me. I'd be happy with any of those. Great question. Thank you.
I think that's one of my favorites as well, is the Bugatti as well, or Maserati. Yeah. I like Maserati. We've just got a couple on YouTube as well, just from Jocelyn Ray. It's, what sort of skills would be required to be an engineer?
Well, as I mentioned, we really do solve problems. So it's a bit of problem solving. You know, if you can find out why something's going wrong or how you want to improve something, it's a bit like being a bit of a detective. You need to work out what's gone wrong and how you might improve it. And at the same time, when we try and improve things and design things, you've got to take into consideration some important factors. You know, how much money have you got to spend? How much time have you got to fix it? How long will it take to actually get the fix into the vehicle and done? You know, so you have to think about a lot of constraints as well as trying to fix it. So those are the sort of skills I would say: a curious mind, problem-solving mind, and just the desire as well to sort of fix things and improve things.
So we've got one from Callum Walsh here. It's, how did you first enter the field?
Hi, Callum. That's a good question. Well, once I'd realised after my WISE course that I wanted to be an engineer, I studied mechanical engineering at Bristol, and then applied for lots of different jobs after that. And I knew I wanted to work in automotive. So that was pretty, from an early age, I sort of knew it was automotive that I was interested in. And I applied to Honda and Toyota and Ford in the UK. And I was lucky enough to get the job at Ford. So they're a great company to work for, and I've been with them, as I say, nearly 25 years now.
We've got two questions from Andrew. So we've got, the first one is, how many different parts are there in one engine?
That's a great question, Andrew. Typically, we've got around 200 different parts in an engine.
Wow. And the second question is Ford still designing petrol engine cars or only electric hybrid cars?
Yeah, that's another great question, Andrew. So we believe that there's lots of different solutions to trying to meet and satisfy the CO2 and emissions requirements. So we are launching 14 different types of hybrids electric vehicles this year. But we are also focusing on our petrol engines to try and make them more efficient and better for the environment. And we can do that through some clever designing. You know, I talked about problem solving, and that is one of our problems. We try to resolve the CO2 emissions and get the engines as light as possible, as cheap as possible, with best quality. So that's all about problem solving. And as we move into our next generation of engines, that's what we're looking to try and do, is to improve the CO2 and meet the emissions requirements.
Thank you for those questions, Andrew, and thank you for the answer there, Sarah. The next one, it's just from someone called ZK. I'm not sure the full names, but it says, why did you want to work for Ford instead of any other car company?
Yeah, so Ford is a great corporate global company. And, you know, I talked about the travel and the expanse. You know, we have design centres and manufacturing plants all over the world with Ford. And that really appealed to me, the idea of some travel, some real global experience. A lot of our engines that we build in the UK actually go into many different vehicles across the world. And so that is something that I'm very excited about. It's great to see vehicles on the road here that I know have got my engines in it, but it's also great to see that they're globally as well. So I think that was one of the attractions with Ford, how its global expanse and the volume of units that we sell. And also I knew Ford was a very family orientated, very focused on their employees. And over the 25 years with Ford, you know, as I say, I've had many different roles. So working for a large company like that means that you can move around and have different types of roles.
Just a question from Carolyn Bishop. Are there many other women working where you work?
Hi, Carolyn. That's a great question because I think probably everyone's aware it's not usual to see a sort of 50-50% split in the engineering world. It is mainly male dominated. In Ford, we are roughly on average with the rest of the automotive industry in terms of how many females, but it's around 10%. So it is very low, but that's what I've experienced since being at university. And there's lots of initiatives and organisations out there trying to encourage young girls to think about engineering as a career. And we need boys as well. This is why I'm here today, to encourage you all to think about engineering. But in particular, sometimes automotive engineering isn't seen so attractive for females. But I would say, I've had a great experience in the automotive industry, lots of different roles, and I would recommend it to females. But you're right, we're running at about 10% of female engineers within product development at Ford.
Brilliant. We'll just ask some questions from YouTube, so some more have come through as well, and then we'll get back to some of the questions from Zoom. Just a question from Graham. What do you think the cars of the future will be like?
Well, that's a great question, Graham. I wish I had an eye. It's very hard to predict, isn't it? I think definitely we will see an increase in the hybrids and electrics. And we do need to try and be more environmentally friendly. And that is one of the challenges. And we're going to need young engineers like you coming through into the industry to help us fix that. So I think, yeah, we will see a change, but it'll be quite a slow one. It's quite hard to set up the infrastructure for many of these hybrid and electrical vehicles. But that clearly is a way forward for some of our bigger cities and how we want to move around big cities. We have a dedicated mobility team within Ford trying to work on inner cities and understand how we would like to move people around the city. So I think transportation will change. We might see a lot more automated vehicles. We may see a lot more car sharing or vehicle sharing, and use those to try and minimise the traffic in very big cities where it can get very clogged and very congested.
We've got another question from Jocelyn Ray as well on YouTube. She said, would you say you prefer the more hands-on part of engineering?
Yeah, that's a really good question, because you can do both. The experience that I had in the factory, where literally I'm wearing safety shoes and I've got my high-vis jacket on and my plastic glasses to protect my eyes, and being really hands-on, fixing problems on the line and trying to make sure that production line is going all the time is really satisfying. You get that immediate feedback that you fix something, and when you're out driving around, you see one of your vehicles on the road. That's very, very satisfying. You feel very proud about that. On the flip side, if you're away from the factory and you're doing more of the upfront design, so typically where I am now, we're working on designing new engines that will be in production in 3 or 4 years' time. So that's very much a different type of work in terms of designing and developing and testing those new parts and new engines. That's a very different world. So which one do I prefer? I'd probably say I prefer the manufacturing experience, just because you get that immediate feedback when you fix something and something gets implemented. You can really see the difference. That was very satisfying for me.
So the next question from ZK again is, what inspired you to become an engineer?
Oh, that's a good question, ZK. I think inspired was, I'll go back to that weekend that I had in the London University, Imperial College, where I met some real female engineers, and seeing them doing what they do and thinking to myself, well, this could be something for me. That has been very inspirational for me at the beginning. And then I would say throughout my career at Ford, I've had some very inspirational role models, both male and female, that have spurred me on to where I am today. Good question.
And then from Hannah Ray, is being an engineer hard work?
Yes, I think so. It's a lot to study. It is hard work, as in, you want to design it correctly, you want to make things better. And, you need to put some energy and some time and effort into delivering that. And, I mentioned some of the, engineering is all around us. So, yes, I work on cars and engines, and we need to make sure they're designed safely and protect the customers. But other areas of engineering, if it's medical engineering, designing new hips or joints for people, that's a very satisfying and rewarding. A lot of work going in at the moment, as we know, the ventilators, to try and help design and improve the ventilators and the number that we have at the moment. That's a very satisfying role as well, but it needs a lot of hard work. So I would say yes, hard work, but very rewarding and very satisfying.
So we've got a question from Rashantha here. It's, if an engine doesn't work, would you have to dismantle it and rebuild it again?
Yeah, that's a great question. And it really depends on the type of failure. So the engine is made up of around 200 components, as I mentioned. And so, yes, when we have an engine that's faulty, it may be just a simple exchange of a turbocharger or injectors. But if we've got some damage in the head or the block, that might drive the need to replace the engine completely. So it really depends on the type of failure. But we try and design our engine and our engine parts to make sure they are serviceable, so that we can minimize the cost and the impact to the customer if something does go wrong, that we can exchange parts easily without having perhaps to take the engine out of the vehicle, for example. We'll try and design elements or parts of the engine that can be replaced and repaired while still in the vehicle. So that saves some time and money, etc. But it really does depend on the type of failure.
So we've got a question from Caroline Bishop. It's, what's the best piece of advice you could give to someone wanting to be an engineer in the future?
Okay, well, I would say keep up your maths and your physics and chemistry, so the technical subjects, as far as possible. And I studied mechanical engineering, and that's a very broad-based engineering versus perhaps civil engineering or aeronautical engineering. So keeping your options wide open, because as an engineer, you can switch between different industries. That is possible, especially if you have a mechanical engineering degree. So if you are thinking of going into engineering, that would be one way to try and keep your options open. So that would sort of be the advice I would give, because there's so many different types of engineering that you could be involved in. Keep your options open. And I should mention, as well as doing, thinking about a route, doing an engineering degree, there is higher apprentice schemes out there, which are also a great way of studying and also working at the same time with the companies. That's another option that allows you to keep your options open as well.
Just a reminder to those on YouTube, if you want to type in some questions as well, you can use the chat section. We've got another one from, I think it's from Lola, this one's from. I am really good at drawing and making things. Would I be a good engineer?
Hey Lola, yeah, that sounds like a good skill to have. Having that creative element is really important, especially if you think about designing the new stuff, futuring. We talked about the possible different types of technology, mobile phones, the smartphones that we have, being able to be creative and come up with new ideas and then get those ideas and draw them. That really helps people to understand your ideas and thoughts. Within the car industry, we're looking at all the time the instrument panel that's in front of you, and even our seats and how we design our seats and the instrument panel. All those areas that you touch and feel, we're always looking for new ideas about how we can help the customer when he's driving to drive the vehicle and make driving a more pleasurable experience. So all that needs to be creative. We always need to be thinking about new ideas. So if you are creative and you can get your ideas down on paper, that's a great skill to have as an engineer.
So we've got a question from Rashantha again. Are Ford working on cars that are able to fly?
No, we're not at the moment. No, I don't think that's something that's in our futuring at the moment. What a great thing that would be, though, right? Can you imagine? I guess we can see that, just to mention, there's a lot of development work around drones, and that drones can carry people. I've seen a few YouTube clips on that. So that might be something for the future of carrying people around. But no, Ford, and I don't think any other automotive manufacturer is looking at the potential of flying vehicles at the moment.
I went watching Back to the Future, the musical, before this all happened, and it's the DeLorean, isn't it? That's flying about.
Exactly.
Yeah.
Exactly.
So one from Hannah again. So do you have to manage men a lot? And if so, is it fun?
Well, yes, I do have to manage men and women in my team. And is it fun? Yeah, I guess so. It's very rewarding to be able to get a team performing and manage them and enable them to do their jobs successfully. and I work with a lot of great engineers. So yeah, do I enjoy my job and is it fun? Yes. And part of that is managing a team. And part of that is the reward and successes that you see when our products are on the roads.
Oh, just got a comment from Caroline. She said thank you. So I think that's thank you for answering her questions. Thank you very much, Caroline, for your questions as well.
Well, yeah, really good questions this afternoon, Alex.
So we've got another one from ZK. So what is the most difficult part of engineering?
I think the most difficult part of engineering is making sure, you validate your design, that you check and test and make sure that it works. And that can be difficult because customers tend to use the product or whatever it is. And I'll talk about cars, but you could apply this to anything like mobile phones or any type of product. If the customer doesn't use it how you expect him to use it, then that can be difficult to test. And it's very hard to do a full suite of testing for every single different customer usage. And so that's very, very tricky for us in the automotive industry as well. We understand how a customer drives a vehicle, but if he uses the vehicle in an unusual way. So for example, I can give you an example of the steering wheel. Now the steering wheel is there to drive the car, to make you turn left and right, etc., help you park, etc. But what we noticed, and this is a few years ago now, obviously, we can see that for some customers, they use that to push on to get in and out of the vehicle. So they might use the top of the wheel and push down on that to actually help them get up and out of the vehicle. And so making sure that steering wheel is going to take the load of that customer as he uses it is something that we had to make sure and bake into the design and make sure that works. That's one example. So I think that would be one of the hardest things is to make sure that you test and you validate and you make sure it's going to work under as many situations as the customer's going to use it. But it's very hard to predict sometimes how the customer uses your products.
So we've got a question from Andrew. What is the maximum speed a car can go to?
Well, I should say the maximum speed on a UK road, of course, is 70 miles per hour. But of course, we know in some autobahns in Germany, there are no speed limits. So yes, vehicles can go at much higher speeds and on race circuits, etc. So really, it's that varies depending on the vehicle, but it can be anywhere up to 180, 190, 200 miles per hour, of course. And that's really reserved, of course, for special racing on race circuits.
So we've got another question from Rashantha. Do you get to choose which car you want to construct?
Yes, to a certain extent. Within Ford, there's such a large company that if you're really interested in working on one particular type of vehicle, then you're able to move into that team and work on it. So yes, many of our engineers do have a say on where they want to work and what type of work they want to do, whether it's designing the next Mustang or working on the next supercharged engine or developing new doors for the transits. Then we do have the ability to allow our engineers to work where they would like to work.
We've just got a question from Jess on YouTube. So if you weren't an engineer, what do you think you would be doing?
Oh, if I wasn't an engineer, I'd probably be like an accountant or something. I probably would have gone down the maths route. If I hadn't have done that engineering course in the university when I was 16, 17 and met some real engineers, I think I probably would have ended up being a number cruncher because maths I really loved and found it easy. So yeah, probably an accountant or something like that, which doesn't appeal to me now at all. So I've been very lucky to be working with Ford Motor Company for the last 25 years. It's a good question.
Very good question. So we've got one from ZK again. So why is it that mechanical engineering is more broad than the other factors of engineering?
Yeah, so mechanical engineering just covers a wider broader spectrum of topics. Whereas if you did choose to do civil or automotive, so civil or aeronautical or chemical, for example, they tend to just, the topics and the subjects you'd be learning are more targeted to allow you to come and graduate as a civil engineer and aeronautical engineer and go straight into that business. Whereas mechanical engineering, because of the types of studies that you'll do, keeps it much broader for you. So you could take some of those topics and then apply them to be a civil engineer or apply them to be aeronautical. So I think that's why I said that the much broader type of engineering is to stick to a mechanical, or even, I mean, I should say as well, electrical engineering as well. And, you know, electrics are becoming more and more important in everyday life. So electronic engineering as well, electrical engineering is a very broad-based engineering topic to study as well. Hopefully that helps.
So we've got one from Callum Walsh. Do you believe handcrafted products are an outdated industry?
Oh, Callum, I'm not sure what you mean by that. When you say handcrafted products.
I'm thinking, does it mean not using kind of machinery?
Yes, so no automation and more hands-on. Do you think that's what it means? I don't know if Callum can.
I'll see if he.
Respond.
If you just put another question in, Callum, maybe.
It says yes without. I can see yes without machinery. So is it outdated? Was that the question, Alex?
Yes. So do you think it's an outdated industry?
I don't think so. I think there's a need for a mixture of the two, right? So if you're mass producing, like we do at Ford, 2,000 vehicles a day, we definitely need some machinery for that, right? But I've also been lucky enough to see the other extreme. I've been able to go into an Aston Martin factory. And Aston Martin cars, as most of you know, very, very expensive cars. And they build around 12, 15 vehicles a week. And it's very much handcrafted. So at the time that I went into the factory, which was probably 10, 15 years ago now, the only piece of automated machinery they had was to deck the engine into the vehicle. Everything else was by hand, and that was amazing. So I don't think it's outdated. There is definitely, you know, we need a good mix. It depends on the volume that you're making. If it's mobile phones and you're making a lot of iPads and Samsungs, then you're going to need some machinery. But if it's a more crafted, hands-on, something unique for customers, and it's very small volumes, then there is no need for that machinery. And sometimes it'll be cheaper to use labour and use people to assemble. Okay, Callum, hope that answers your question.
Yeah, thank you, Callum. So from Carolyn Bishop, we have one. Do you think combustion engines will eventually only be found in motorsport?
Yeah, good question. No, I think there's always going to be a need for combustion engines if you think about some of the commercial uses. So for some of our trucks and lorries and some commercial applications, we're always going to need combustion engines because they only really do deliver the power and torque that will be needed over a certain distance and time. But I think what we'll see, the more mix of hybrids, electrical vehicles in inner cities, where there's good charging facilities, etc. So I think that will always be a need for it. And in motorsport, we're already seeing some advances in technology on electrical usage and batteries. So actually, typically from motorsport, and in particular Formula One, we tend to gain a lot of knowledge and technology advancements through what they're doing. So let's see. That's a good question. Now I like that one.
So we've got one from Lola Ray again. So is engineering mainly about making things or inventing things yourself?
Yeah, I think inventing things, making things, seeing a product, you know, something comes out of it. You know, it's a combination of designing, engineering skills, and then you actually get the physical product at the end of it, which is very satisfying. And as I say, problem solving in terms of making it better, improving on something as well. That's also what engineering is about as well.
And then one from Rashantha. So what is your favourite part of working at Ford?
Oh, favourite part of working at Ford? I think it is, working with other engineers and improving and making some great products for our customers. So every time I see a Ford on the road, I'm very proud to be able to say that I work for Ford. We've got some great products that we're designing. And I think working with a great team of engineers and being able to really make a difference is the best thing about working at Ford, I think. These questions are good this afternoon, Alex.
Some very good questions, and they keep coming in, which is brilliant. Everyone very engaged, so thank you, everyone. Next one from Lola again. Do you have to do things? Do you have to do lots of training courses, to become an engineer?
I'm not sure about lots of training, but there is definitely training that's needed and ongoing training. So, we talked about doing degrees, mechanical, electrical engineering degrees, or doing the higher apprentice route where you do a degree, but you're learning on the job at the same time. And training is required, ongoing training, because technology is changing all the time, right? So especially for us at the moment with the hybrid and electrical engines that we have, that's training that's required by our engineers, and we try and develop and make sure we're always learning new technologies. And I think that's true of any profession, not necessarily engineering. I think within any profession you'll find there's always ongoing training and development to make sure you're up to the latest level of technology or knowledge in your particular field. It's always important to keep learning and making sure you're improving.
So another one from Rashantha. Is the comfort of a car different if it is constructed by machinery instead of by hand?
Well, I would say it will be different. I mean, if you take the example of premium cars, and Aston Martin, for example, then yes, the materials they're choosing will be different to something that you find in a Ford or a VW, because of the cost difference. Cost is a big driver. We're trying to make affordable cars with good quality. So our seat designs take that into consideration. And when you're producing large volume, you're going to need machinery to make those seats. But for an Aston Martin driver who's prepared to pay a lot of money for his car, and he is perhaps on his seat, he's going to have not only a heated seat, but air-conditioned seat as well. And he'll want a massage in there as well. All those cost a lot of money. So that would be the difference. But both companies, all automotive manufacturers, would strive to make the best quality seats for the price of that vehicle.
Ooh, another one from Hannah. Can you describe a typical day in your job, please?
Okay, well, typical day in my current job as Chief Engineer for Engines. Well, it'll probably start with having a cup of tea. That's the first thing, make a cup of tea. And then I will probably check my emails and look at my diary, my schedule for the day. And throughout a day or a working week, I'll have a number of different meetings with either my team or with other cross-functional teams. And they can range from having a team meeting with my engineering managers, making sure everybody's working on the priorities and everyone's working on the right tasks for that week. I might also meet with my engineers to approve some of the recent design changes that we need to make to the engines. So I'll be checking and reviewing the design change they want to make to the engine, whether the cost is appropriate, whether it's correct for quality, and what the timing of the change would be. I might also meet with my purchasing and the buyers to make sure that they're buying our engine parts at the right price and make sure that's working correctly. I will also have a quality meeting to make sure any quality improvements. We'll look at some of the warranty data in the field and make sure we are checking to see what engine failures we might have seen and what fixes we can put in place to try and improve them. And we might also meet with our advanced engineering team about changes that are needed to engines to meet the future CO2 emissions. So that would be a review of what's required to meet some of the legal requirements that are coming in on emissions and how we're going to satisfy that requirement for design changes.
So we've got one from ZK. How long have you been working for Ford?
Yes, I've been working for Ford for nearly 25 years now. That's a long time. And so I'd say great company to work for. Any large corporate automotive company is great because as you move between different departments and different roles, you are learning new skills, you've got new training to do, you're working with different people, different environments. And so that 25 years can go quite quickly.
Well, their next question says, what car company would you want to work for other than Ford?
Who's asking me that question?
It was ZK again from the previous one.
Honestly, ZK, I'm going to say Ford, of course. I'm very loyal to Ford. They've been a great company to work for. And yeah, I think I would have to say I would have to choose Ford.
So we've got another one from Lola again. So can engineering be in any way about discovering things?
Discovering things. So let's see. I mean, yes, I would answer to that. And I'm trying to discover things as in there's lots of new features that we discover in our vehicles. Most of you, for example, I'll give an example of the windows in the car. Most of you will have the window will move up and down. Well, not so long ago, it was a mechanical device, and you had a wind that would wind the windows up and down. And yet we discovered a way to try and make that easier for the customer, where he just presses a button and the window, the glass moves up and down. So that's a very basic example on a vehicle, but there's lots of discoveries that are being made in the engineering world. You think about your iPhones, you think about the mouse that we use on laptops, how that was discovered. So I think there's lots of examples of where engineering has played a significant role in making those discoveries. And that, for me, is what is so exciting about being an engineer and being part of that, and part of the opportunity to have these discoveries and make the world a better place through finding those opportunities.
Just before we answer a few more questions, we just got a comment from Carol. I think she's left now, but she said, thank you so much to Sarah and Prime Engineer. This was a great interview, but they had to go. But just a nice comment from Carol, and thank you, Carol, as well. Just to those as well who are still on, if you could subscribe to our YouTube channel as well, for this interview will be recorded and put on there, and there'll be other interviews as well in the future. So if you could please subscribe to our YouTube channel, that would be fantastic. We've got another question from Lola again, Sarah. So I like this question, so because you make cars, do you get any for free?
Well, I don't get them for free, but I do get them at a very special rate. So yes, if my family and friends, if my family would like to purchase a Ford vehicle, then I get a very good discount that they are entitled to. And as a manager at Ford, you're entitled to a management roll car. So that is at a discounted rate. But unfortunately, we don't get them for free. That would be really nice, though, wouldn't it?
And we've got actually a question that leads from this, from Jess. So what car do you drive?
Yes, I do have a Focus ST. And I think I mentioned that with one of my favourite vehicles is a Ford Focus ST. So yes, that's what I drive currently. I
really like the look of the Ford Focuses as well. They are really, really nice cars. So we've got another one from Rushantha. So what is the longest time it takes to build a Ford car?
Longest time it takes to build a Ford car? Well, from start to finish, and it'd be really good if you look at the YouTube clip that we posted in the chat section afterwards, because that shows a very speeded up film, but of what goes on inside one of our factories. But from start to finish, and start for me is actually the body parts being stamped out. So we have huge foundries and presses that press out the metal parts of the vehicle, and then we weld up the vehicle, and then it goes into paint, get painted, and then it will go into what we call our trim and assembly line, and all the parts start getting assembled to it. And then finally, once it's assembled, we do a series of checks and tests on it as well. So from start to finish, it's typically 3 days from a starting point to the finish.
And we've got one from Susan again. So what do you think about apprenticeships?
I think apprenticeships are a really great way to combine studying with actual paid work. So apprenticeships, you know, you will work on a degree with a university or a college, and the company that you're working with will actually pay for that study and pay you when you're working, do your work assignments as well. So it's a really great combination of learning and then hands-on, being involved in the learning experience is a really good combination versus a degree, which very much everything being taught at you, and you might get a year out in industry. But a high apprentice scheme benefits both an employee and an employer, because the high apprentices we've seen at Ford have been great, and they learn a lot. And when they come out and they finish their degree, we're able to offer them a role within the company as well, assuming that they've achieved their degree, of course. But we are able to take them on board, and that's great because they've been with the company for a number of years already as they've been studying. So yeah, they weren't when I was studying in the same way. So I think if I was to study again, I think that might be a route that I would seriously look at.
Yeah, I think Susan's next question was, do Ford offer apprenticeships and how do you apply for them? So yeah, I think you've kind of answered that there, haven't you, Sarah?
Yes, we do. We have offered hire apprentices. I don't think we're hiring at the moment, but if you check the Ford website, ford.co.uk, there'll be information on there.
Fantastic. So we've also got another question from Lola, some fantastic questions from Lola today. Because of coronavirus, do you still go out to do your job, or do you do it online instead?
Great question. And I am working from home at the moment. So yes, I am able to work from home currently.
And then another one from Rashantha. So because you work with engines, do you have a separate place in the factory to work?
Well, we do have separate engine plants versus our vehicle plants. So the YouTube clip that you'll see is the Fiesta vehicle plant in Cologne, but the engines that go into Fiestas are in a separate area, and there's a separate assembly line. So we'll typically build our engines in our engine plants, and there's one in Dagenham in Essex where we build a lot of diesel engines, and then those engines are then shipped out to our vehicle plants across the world for them to be built into the vehicle plants, into the vehicles, excuse me.
We've got another question from Jess. So aside from your qualifications, have you or your designs ever won any awards?
Oh, that's a good question. No, when you say awards, we have got an award system within Ford. So I've received some acknowledgement and achievements for that. Externally, we would refer to patents, where you patent a new technology or a new design. That's very satisfying. I don't have any patents, unfortunately, but I know a lot of my colleagues do. And that's a very satisfying way to acknowledge you've designed something new or something different to other engineers. So patents, we have a lot of our engineers who do have patents. So yeah, awards, but I would say internally within Ford.
We've got one from Callum Walsh. If you're looking for a fault in a car, would you say you can find those faults quicker now than you did when you started? And if so, do you think experience is helpful to do this?
Yeah, good question, Callum. Yeah, you're right. Experience really helps because if you've seen an issue before or you've seen something similar, you can quite quickly then get to the root cause and work out why and what's going wrong and then try and fix it quickly. I would say on our vehicles now, we've improved a lot our diagnostic ability from the vehicle. So we are able to hook up a certain tool and software and read engine codes that are produced by the engine when something goes wrong, or by the vehicle when something goes wrong. And that helps us to quickly work out what's wrong, whether it's a temperature reading that's incorrect or an oil level that's wrong. And that can help us diagnose faults very quickly. So yes, we have got better at designing software and tools that allow us to identify problems much quicker. And even more smarter and more clever, I think, is we've moved into using what we call modem technology, where we can remotely access a vehicle, and it's when it's with the customer, and we get data that's sent back to us remotely that we can diagnose and work out if a vehicle with a customer has got a problem or not, without them having to bring it into a dealership. So, for example, if a transit vehicle with a diesel engine might have an issue with its oil level, we can actually monitor that vehicle and identify that it's running low before the customer is even aware that he might have a problem. And what we've done recently is we've been reaching out to customers and telling them before the vehicle breaks down, before it fails, that they've got an oil level issue, and that allows us to fix it quickly, reduce the damage on the engine, and obviously reduce the fact that the customer wouldn't have his vehicle for a number of days while we repaired it. So that modem technology is something very important and that Ford is using currently.
So we've got one from Rashantha again. Do you have to be a certain age to work at Ford?
No, you just, we have engineers of all ages, and if you join Ford after you've studied your degree, then you're typically around 21, 22 years old. But as I mentioned, the high apprentices, they're as young as 17, 18, so they're finishing their A-levels, and they come and start working for us then. So we do have apprentices that are very young, right through all different ages.
And then if another one from Rashantha, if you want, can you construct a whole car by yourself?
Could I construct a whole car by myself? I think that answer would be no. It takes quite a team of people and some level of machinery to assemble a car. But I think you're aware there's many classic cars out there where people are repairing and restoring cars in their garages, and that can be a single person restoring and repairing a vehicle and building a vehicle, so that is possible. But no, I personally wouldn't be able to do that all alone. I would definitely need a team of people around me.
And another one from Shantha, are Ford working on self-driving cars?
Well, there are different levels of self-driving. So we already have a level of self-driving capability within some of our vehicles, some features. So for example, if you're driving along and the car in front of you suddenly brakes and you haven't noticed or you don't react in order to brake to avoid hitting the car in front of you, the car will take over and put an automatic brake in place. So we have sensors that are able to monitor how far that car in front is. And if it slows down and you're not reacting to it, then our cars will put a brake system in place to avoid you hitting that car. So that's one level of self-drive we've taken over from the driver. But then there's different levels. And I think what you're saying is self-drive as in like some of the self-drive vehicles around where you can take your hands off the steering wheel and sit there on the motorway and it will drive for you. So we're not at that level currently, but there are vehicles around like that. I think there's quite a lot of work to do still in design work and testing and validating of how we would use that type of technology in our vehicles. But potentially that is something for the future.
So we've got one from Susan again. If the other countries you have visited, are there more female engineers than in the UK?
Yeah, that's a great question, Susan. So yeah, typically in the UK, the number of female students is lower than other female engineers and students is lower than other countries. I've noticed in the UK, sorry, in America, in Turkey, in Germany, and in Spain, the level or the numbers of female engineers is higher than the UK. So I do think there's something specific with the UK, and there's some studies and surveys out there that state that as well. We do have a misconception, or sometimes a misunderstanding about what engineering can and could be for people, and therefore that can put people off, I think. So that's why I think this primary engineer scheme is fantastic for a fantastic organisation to help primary children really understand what engineering is at a young age, so that they can get interested in it and be our future engineers. That's what we need in the future.
Another one from Lola again. So if you have to stay at home, does that mean much less cars are being made every day?
Yes, Lola. So that's correct. At the moment, with the unfortunate COVID virus, all of our vehicle plants and engine plants have shut at the moment for the safety of our workers, and because we are not receiving any orders for vehicles as well. So yes, unfortunately, our plants are shut currently.
We've got one from Richard. It says, how does the paint work? I'm guessing, how do you put the paint onto kind of the cars?
Yes, now this is really super interesting to see. I was lucky enough in Valencia when I was there in the plant, in the factory, to be able to see this. And the painting is quite an art in itself. And there's different layers and coats that are needed. It's not just one single layer of paint. There's a special layer or coating that's used to avoid rust and corrosion of the metal. And then we have different layers of coating to enable the paint to really stick and hold and not get damaged. So it's a very lengthy process. But one of the amazing things that I saw in the factory in Spain was how they literally take the body shell of the vehicle and dip it into what I can only describe as a paint bath. So literally, I'm going to try and use my mobile phone here. This is the front of the vehicle and this is the back of the vehicle. And literally the vehicle, the body will come along and it literally gets rotated 360 degrees all the way around in this bath. So it gets a really good coating and then comes out the other side. It's incredible. I was shocked. It's huge, amazing. But that is the best way, rather than you'll see in other applications. We do have robots spray painting some areas, but they can't get to every single nook and cranny. So having this bath where the body literally gets dipped in this bath 360 degrees, make sure every single area is coated. Amazing, really cool.
Wow, that sounds like an incredible process, and something really incredible to see as well.
Yeah, amazing.
Another one from Hannah. So you mentioned that you travel a lot. Do you have to learn the language?
Right. So, well, one of the interesting things about engineering is that the global language is English. So what you'll find is drawings and any work, any CAD or any design work that's done is typically in English globally. And certainly for Ford employees who work in Germany or Spain, they have to be able to speak English as a second language. Now, for myself personally, I think it's very important to be able to converse and communicate with people in their language. So I have worked in Turkey quite a lot, and I did learn some Turkish, just the basics, nothing really very technical, other than I learned some of the parts of the vehicle, what the Turkish word was. And in Germany, I learned quite a bit of German, and I did go to night school to learn some more conversational German as well as some technical German. And whilst I was in Spain for 3 years, of course, yes, I did take some lessons and learn Spanish. But all the meetings, all the technical discussions are done in English.
So, thank you so much for answering these questions, Sarah. There's 3 left. Are we okay to answer those last 3?
Let's go for it.
Fantastic.
Come on.
There's been an incredible 44 questions we've had, so I think that's been amazing. So one from Rashantha: if there is a shortage of engineers, what would happen?
Yes, that's a really good question. That could have been the last question as well, Alex, because that's a great one to end on, because I would say that troubles me a lot. We don't have enough people studying engineering currently, and therefore the prediction for 2020 is that we're not going to have enough engineers to deal with all the requirements we need to improve the environment or the climate change issues that we're facing. we really do need engineers to try and solve some of these problems. So I think that's a great question, and things would start to stop improving, right? And we could really be in a dire situation. So that would be my plea, that everyone thinks about, could they and would they be an engineer to help solve some of the future problems of the world?
So we've got one from another one from Callum. Do you think that electrical components are overtaking the mechanical sides of the car?
Yeah, that's a good question, Callum. And yes, we certainly use a lot more diagnostic tools. So we're taking what we'd say electrical readings off the vehicle to try and work out what's going on. And we're using a lot more features and technology in the vehicles. So when I described about the self-driving and the vehicle automatically stopping to avoid a collision and taking over from the driver, that involves a lot of sensors, a lot of data reading constantly, and algorithms to work out how the car is being driven and where it's being driven. So for sure, electrical engineering is key, and that is a growing area for our engineering teams as well.
And then just last one from Richard. He did say, how does an engine work? Which I think we've already actually covered that question, haven't we, Sarah? But he's also said how many people work for Ford as well.
Oh, how many people work for Ford? That's a great question. So globally, it's thousands. I think it's like almost, I think it's something like, I might have to Google that myself, you know. What I can tell you in the UK, if we stick to the UK, I can talk knowledgeably about the UK site. We have a research and development site in Essex at Dunton. And we have over 4,000 people working at that facility that are involved in designing next generation transits and powertrains. And in our manufacturing sites, though, we have a number of manufacturing sites in the UK still building engines. We have thousands of people working at those as well. So that's a really good question. I should know that, but I guess I'm going to have to Google that after this interview, I think. So I know that for next time.
Yeah, that's a really tough one. To be honest, I don't think I know how many work at primary engineer. So I think knowing how many work at Ford, that's a really, really tough one. Thank you. There's been amazing 45 questions there that you've answered, and then not including the ones on YouTube as well. We've had a few on there as well.
Great.
So thank you to everyone. Can I just end on the last one, Sarah? If you were doing the Leaders Award, what would you think about? What would you invent, do you think?
Ooh.
Or would you need some time to think about that?
You save the best one to last. Well, let's think. I think I'd like to have, we talked about seats earlier, but I think our seats could be designed better. You know, I talked about how comfortable they are. You know, I'm quite a tall lady, so whenever I sit in the seat, it's never quite right for me. And maybe getting in and out of the seats, you know, why doesn't the seat twist around so I can step out nicely and swivel back in again? Maybe that's something I'd want to try and improve.
I think that's an amazing idea, and I think you might have to pattern that one as well. Thank you very, very much, Sarah, for answering all those questions and for your presentation as well. I think it's been an amazing interview and a great success for our very first one as well at home. I hope everyone has enjoyed it. If everyone could fill in, I've linked in a survey into the chat. If everyone could fill that in, I know you might want some feedback as well, Sarah, about the interview. So that would be really good if people could do that. If people could also subscribe to our YouTube channel. So we'll be doing lots of interviews on there as well. And we'll be doing some more people from Ford as well, Sarah, which would be fantastic. And yeah, just a really, really, really big thank you to you for doing this today.
Thank you very much, Alex. It's been a pleasure. I've really enjoyed it. And I had some tough questions there, though.
Yeah, very tough question. Lots of questions, very tough ones, but really well thought through. So thank you very much, Sarah. I think we'll end it there. Bye.